Hi everyone, this is our work DuET, Dual Incremental Object Detection via Exemplar-Free Task Arithmetic, developed at Sony Research. Real-world environments are dynamic and demand object detectors that can adapt to new objects and changing conditions over time. Traditional detectors trained once on fixed data fail under such domain or class shifts. Let us first see what existing approaches offer. Existing methods are either class incremental or domain incremental. Class incremental models learn new classes but fail in unseen domains, while domain incremental models adapt to new domains but cannot detect unseen classes. Hence, we need a unified framework to handle both. We address this gap with Dual Incremental Object Detection, or DuIOD, where models learn new categories, adapt to unseen domains, and do so without storing past data. The goal is simple. Detect all learned classes across all encountered domains, retain past knowledge, adapt to new ones, and remain exemplar-free, meaning no replay of old data. Here's a quick look at the overall DuET framework to tackle DuIOD. In the next few slides, we'll build this framework step by step to understand each component in detail. We start with a generic object detector, where backbone and neck parameters are shared across tasks, and the detection head is task-specific. Now we introduce the first task, T1, where the model learns to detect cars and trucks from night-sunny domain. After training, we get model mθ1. For task T1, we use mθ1 as it is for inference. Task 2 introduces new classes, person and bus, from a daytime domain. The model parameters are initialized from task 1, and we compute task vectors capturing domain-specific changes, which help DuET understand how each new environment alters shared representations. The DuET module now comes into play. It merges past and current task vectors using layer-wise retention and adaptation factors. Alongside an incremental head combines task-specific parameters from current and past tasks. Together, these components prevent forgetting and enhance generalization. Finally, the full DuET training flow takes shape. Mathematically, DuET module balances two forces, a retention factor that preserves old knowledge and an adaptation factor that learns from the current task. Each layer adjusts these dynamically to maintain stability and adaptability. Talking about the loss objectives, training begins with a standard detection loss for the base task. For subsequent tasks, we add a modified distillation loss and a directional consistency loss, or DC loss. To resolve conflicting weight updates during model merging, we introduce DC loss. As shown in graphs, applying DC loss reduces sign conflicts and significantly improves the retention adaptability index. Importantly, DC loss remains object detector agnostic and can be applied to different detection backbones. We evaluate DuET on two dataset series, Pascal series with 4 visual domains and diverse weather series with 3 weather conditions. To measure both retention and adaptability, we introduce a unified metric, the Retention Adaptability Index, or RAI, combining the average retention index and the average generalization index. Higher RI means better memory of old classes, while higher GI indicates stronger generalization to unseen categories. Across all experiments, DuET achieves the best RAI while using fewer parameters than competing methods. Unlike prior approaches which are optimized for specific detection backbones, DuET exhibits broad generalization across a variety of object detectors. Next, in this figure, we can clearly see how DuET effectively mitigates catastrophic forgetting across incremental tasks compared to other methods. In qualitative results also, DuET produces accurate and high-confidence detections even in unseen environments, unlike other methods that misclassify or miss objects under domain changes. Next, we can see the contribution of each component and losses in improving the overall performance. In this table, we can see that DuET is not affected by the order in which classes or domains are introduced incrementally. In complexity analysis, we can see that DuET preserves the real-time inference speed of its base detector and does not increase memory footprint, unlike other task arithmetic approaches where memory grows linearly with tasks. In essence, DuET marks a step forward in incremental object detection, paving the way for truly adaptive and scalable real-world vision systems. Thank you. Please scan the QR code to access our full paper.